Welcome back to another one of my applications of differentiation videos. This video will be focusing on the Rolle's theorem and the mean value theorem. No equations or anything are going to be used, it's just going to be explaining them and how they work. So here we have Rolle's theorem, and you can use Rolle's theorem when these three exist. So when the function is continuous on its closed interval in this case would be these 2 points. They're not highlighted very well, but these 2 points. When it's continuous, which it is, I'll give you some examples when it's not continuous and whatnot at the end of this. But if it's continuous between the two intervals, which it is, it's just one line, so you're all good. The next one is if it's differentiable over the open interval, which means over the function. So, and in this case, yes, you can. What it basically means is, can you calculate the slope on any point? And that's yes, because you can't calculate it on something like a point, but you can calculate the slope on a smooth curve. Okay. Anyway, so those two are all good to go. And if the function of a equals the function of b, which means when you sub in this point a into the function, it equals the same as when you sub this point b into the function. Okay? And when those three apply, when those three are working, then the derivative of c equals 0. Now let me explain how that works. So here you have a point a and a point b. And when you sub them in to the function, you get their y values, or which is the function, what the function will equal, which is function of a and function of b, which is essentially the y value that corresponds with a and the y value which corresponds with b. So when you get that, because in this case a and b go up, and a and b are different values, but the function of a and the function of b equal the same thing. Therefore, the average slope across the both of them is 0 because it's flat. Okay, a and b equal function of a and function of b equal the same. Therefore, it's flat. Therefore, the slope is 0. And the reason that ticks there is because with the mean value theorem, you don't want it 0. Rolle's theorem is 0. Okay, so if it ticks the box of function a equals function of b, then it's flat. And what you are trying to do in both the Rolle's theorem and the mean value theorem is find the tangent line, which is the point at which the tangent line is parallel to the secant line. And that's the secant line there. That's the point. C is the point at which the tangent line is equal to the secant line. So the secant line is where it passes through 2 points, and the tangent line is where it passes across 1. Okay? Essentially, it passes through 1 point. And C, that's what we don't know. We know A, we know B, we know f of A and f of B once we work it out. But what we're trying to find is C. We're trying to find the point where if you put a slope across it, it equals the same as this slope across the two intervals. Across the interval, I mean. And that's why the derivative of C is equal to 0. Because if this line is 0, if this secant line is 0, and you're trying to find the tangent line which is parallel to that, therefore this has a slope of 0, and this tangent line has to be 0. That's why the derivative of C is equal to 0. Now let's talk about the mean value theorem. So just like Rolle's theorem has to be continuous on the closed interval, it has to be differentiable on the open interval, which it is, and you can find the slope at any point, and it hasn't got any chops and changes, it's just a smooth curve. And the function of a doesn't equal the function of b. Okay, that means we have 2 points, a and b, and that trails down to b, and that trails down to a. We have 2 points, a and b, And when we sub them into the function, they do not equal the same. That means that it's like this. There's an actual slope. It's not a slope of 0 anymore. If b was below a, it would be a negative slope, and if in this case where b is above a, it's a positive slope. Okay, and what we're trying to find, this is the secant line, and we're trying to find the tangent line which is parallel to it, and that point. The point at which the slope, its tangent line at that point, is equal to the secant line. Okay, so we're trying to find C, and C is equal to that point. F of C is equal to that point, and the derivative of f of c at that point is the slope. Okay, and that's we use this here to find C. And that's what this equation's for. In the other one, because the slope was equal to 0, the slope of the secant line was equal to 0, therefore the derivative of the line that would be parallel to it has to be 0. In this case, the secant line isn't 0, and the way we find that out is we have function of b minus function of a over the b value minus the a value, and that there is just another way of writing m equals y2 minus y1 over x2 minus x1, which is saying you basically have the y value, because you have 2 points, you looking at the y value up here minus the y value down there, divided by the x value of this point minus the x value of this point, and that's what you get. And that's the same as this, because m is the gradient and this is the slope, which is the gradient. Okay, so basically the derivative of c equals this. That's because this is the secant line, and this derivative of c has to equal that because they're parallel. The slopes have to be the same. And when you find that, when you get this far, you can find c using this equation. And so that's basically it. I'll give you an example of non-continuous function. So if the function chops and changes, that's wrong. You want it to be smooth and you want it to all connect up. You don't want this. This is bad. And when something is non-differentiable, that's when it has sharp, it goes like it's going down and then all of a sudden it goes up. Like it's supposed to curve, or it's supposed to move into a different direction. It can't just chop and change into a different direction when it wants to. Because this is, you can find the slope here, but you can't find the slope at the point because it's going down, then all of a sudden it's going up. There's no slope. You can't build into it. There's no slope at a point. And just like this, it can curve down, but if it stops and then changes, that point, it's not differentiable there. What you want is something like this. I'm pretty sure this is the x cubed function, roughly. And that's basically just starts and goes smooth, nice bends. That's the sort of thing you want. Anyway, that's enough from me. I hope you learnt something. Thanks for watching, and stick around.